Hey everyone, welcome back to my YouTube channel. So before we start the video, if you are new here, do not forget to hit the like button and subscribe to my YouTube channel and share this video with your friends. In today's video, we will learn about Gaussian elimination, and we will implement or give the pseudocode for this one, and we will solve a sample problem to make you understand how to solve a Gaussian elimination. First of all, what is Gaussian elimination? Gaussian elimination is a systematic procedure for solving a system of linear equations. For example, you have been given a system of linear equations ax equal to b. We will solve this system of linear equations by transforming the augmented matrix a b into an upper triangular form, and then we will do the back substitution. It is one of the fundamental algorithms in linear algebra. Now I will give you conceptual explanation and pseudocode, and then I will give you the numerical issues, that means pivoting and complete numerical example. So the idea behind it is that first of all we will form a augmented matrix out of the system of linear equations, and then I will implement the forward elimination. How are we going to implement that? We will use elementary row operations to eliminate entries below the main diagonal, producing an upper triangular matrix U, so the system becomes Ux equal to C. And then we will apply back substitution. We will solve for variables starting from the last row and moving upwards. And elementary row operation used is we will replace row I by row I minus factor into row k. And factor, how are we going to calculate factor? Factor will be aik divided by akk, and this will zero the lower triangle. That means this zeros the entry in column k for row I. Okay, so this is the pseudocode. So let's understand this pseudocode. First of all, AB is equal to A comma B, and here A is the coefficient matrix, B is the right hand side column, and A comma B combines them into a single augmented matrix. I hope you understood this row. And then also this makes it easier to apply row operations on both coefficients and RHS together. After this step, your matrix will look like A and B. Okay, and then comes the forward elimination. For k is equal to 1 to n minus 1. This is our outer loop. Here k represents the pivot row and pivot element AB k comma k. Okay, and then comes the inner loop. Okay, and this runs for I is equal to k plus 1 to n minus 1. And here we are eliminating values below the pivot in the same column, and each row I is updated using k. Factor is being calculated as factor is equal to AB I comma k divided by AB k comma k, as I mentioned here. Okay, I am updating the row I by row I minus factor star into row k. You can see row I equal to row I minus factor into row k, and then inner loop is ended, and when k is equal to n minus 1 is reached, the outer loop also ends. Okay, now coming to the back substitution. First of all, we will initialize the solution vector x is equal to 0 n comma 1. This will initialize all the zeros inside the x vector, and then xn will be calculated as AB of n comma end divided by AB n comma n. Okay, because the last equation is an xn equal to bn, that's why it is being defined as xn is equal to AB n comma end divided by AB n comma n. And we are looping for remaining variables. For I is equal to n minus 1 down to 1, xi is equal to AB I comma end and minus AB I comma I plus 1 to till n into xi plus 1 to n divided by AB I comma a. So the final output is at the end vector x contains the solution to the system, and you have solved ax is equal to b using Gaussian elimination. Coming to the forward elimination, I will explain the pseudocode and explain the algorithm behind it. At step K, you use the pivot AK, K, diagonal element of row K. For example, row K. This is AKK, that means A22. Okay, to eliminate all entries below it column in column K. For example, like this is column K, that means K is equal to 2, and all these values will be made 0. And for each row I greater than K, that means this we will compute factor ai comma k divided by akk, and then set row I is equal to row I minus factor into row k. And after finishing all k from 1 to n minus 1, you have an upper triangular matrix. That means this matrix. Okay, now coming back to the back substitution, and what happens here after elimination, we have for row I ai into xi plus ai I plus 1 into xi plus 1, and this is the equation for row I we have, and we have already computed for xn. So for general I from n minus 1 to down to 1, how can we calculate xi? Xi is equal to bi minus, for example, we are calculating this one. Okay, so starting from here till here, we will sum all the values and then subtract them from bi dash. So that's what we are doing here, and we are dividing it by aii. So that's how we can calculate xi, and this is exactly what this MATLAB line implements. Xi is equal to ab I comma end minus ab I comma I plus 1 to n into x I plus 1 till n divided by ab I comma I. Okay, and this ab I comma end is bii. This one is bii for the current RHS after elimination. Now coming to the sample numerical. For example, we have a system of linear equations 2x plus y minus z is equal to 8, and minus 3x minus y plus 2z is equal to minus 11, and minus 2x plus y plus 2z is equal to minus 3. Now we have a matrix of coefficient is 2 1 1 2 1 minus 1 minus 3 minus 1 2 minus 2 1 2, and constants are 8 minus 11 minus 3. Now coming to the step k is equal to 1, that means we will use pivot a11 is equal to 2. This is a11, this one. Okay, and for row 2 factor will be a21 divided by a11, that means a21 is minus 3 and a11 is 2, and factor will be minus 1.5. and similarly for row 2 equal to row 2 minus factor into row 1. So for example, for minus 3 we are calculating it will be 0, and for minus 1 it will be 0.5, and for this value it will be 0.5. and similarly we will calculate for RHS also. So this will be for row 3 factor will be a31 divided by a11, that means minus 2 divided by 2, and it will be minus 1, and this value will be become 0, and then this value will become 2, and this value will become 1. So now we have a matrix 2 0 0 1 0.5 2 and minus 1 0.5 1 and 8 1 5. Now for the next iteration where k is equal to 2, we will use pivot a22, and a22 is 0.5 here. So for row 3 the factor will be a32 divided by a22, that means 2 divided by 0.5, which will be 4. And now for row 3 is equal to row 3 minus factor into row 2. So what will it be? Like this will be, this is already 0, and this will be also 0, and this will become minus 1, and values will be updated. This will be 5. So now we have a matrix which is 2 1 minus 1 8 0 0.5 0.5 1 and 0 0 minus 1 1. So from here we can find out that 0x plus 0y minus z is equal to 1. So z is equal to minus 1. And similarly for this row 0.5y plus 0.5z equal to 1, and here z is equal to minus 1. So 0.5 minus 0.5 equal to 1, and 0.5 y equal to 1.5 and y equal to 3. And we have equation for row 1 is equal to 2x plus y minus z equal to 8. And when we substitute values of y and z, x will be 2. So our solution will be 2, 3 minus 1. X is equal to 2, y is equal to 3 and z is equal to minus 1. So that was our Gaussian elimination, and that's how we solved a system of linear equation using Gaussian elimination. If you enjoyed this video and you got some understanding of Gaussian elimination, do not forget to hit the like button and subscribe to my YouTube channel, and see you in next video.